Great talk. Lightning talk, lightning precision. That was right on time. So the next talk is going to be from my friend Jean-Francois. He's a technologist with a very wealthy, or a very large wealth of experience. He's currently at IQGeo, and he's going to be talking about the rise of open, disaggregated, and intelligent fiber networks. So take it away, Jeff.
In 10 minutes. I know I'm the last.
Disclaimer, he took this talk from 45 minutes to 10 minutes on my request, so appreciate if he can do it.
I'll try and keep it short. I realize I'm between you and your drink, sponsored by Telehouse tonight, so try and go fast. Please bear with me. I'll rush through these. So I go by JF, as introduced by Mark. Nice to meet you all. Happy to be here today. Quite a lot of years in telecom. I've touched pretty much all of the technologies that the communication service providers use, and always from an automation perspective. So complex use cases that require topology and inventory to be considered are the type of automations I've been working on, and that's what we're doing right now at IQGeo. We're actually automating using AI algorithms, network planning, network design, ordering equipment, construction workflows, and supporting net DevOps teams. So today, I'm going to be talking about the ideal, you're a lot of people working at service providers, and there was a really good presentation from Ductus. I really loved it. What are the business attributes that everybody's looking for? Reliability, speed, and agility. And those were touched on Ductus's presentation. So, did I go back? And agility. So just touch upon really quickly. Reliability is way more than just having your network up. Reliability is how your customer perceives you. Okay? If you're calling because you want a new communication service to be deployed, sorry, yes, you hear me? No, it's okay. Thank you. If you're calling, hello, okay, perfect. If you're calling your service provider because you want a new telecom service, you want it fast and you want it done right the first time. Agility, if your product managers come and say, hey, we got this amazing idea for a new service that all of our customers are going to love, and it's going to allow us to be differentiated. Is it going to take you 2 years to roll that out, or can you do it in 6 months? Because 6 months would be fast. Okay. And so in the presentation today, I'll be talking about, of course, automation as a key tool to make this work. And just as discussed in the Ductus presentation, automation is a broad term. It's way beyond just software. It's about people, it's about processes. And we're going to be talking about free enablers to make that work in your network. So specifically openness, disaggregation, and of course, intelligent data. Who doesn't want intelligent data? Running through this. So what are the, what is openness and disaggregation? I'm not going to spend too much time on this. I figure a lot of people know what openness is. I've always been on the vendor side, so openness is when the vendor actually does an effort so that whatever they sell you can interwork correctly with components or solutions from other vendors. Typically, that involves following standards, but any genuine effort to open it up and make it interwork is fine with me. And disaggregation is about breaking solution to small parts, okay? So instead of buying an entire solution, an entire RAN solution from a vendor, whatever, you want to pick the best of breeds that each vendor offers, okay? What are the advantages of this? So it prevents vendor lock-in. So it's a term that you've heard before. Why would you want to prevent vendor lock-in? Because you might be super happy with your vendor that you have today. Everything you want to do is offered by that vendor. But maybe in 4 or 5 years from now, you want to go in their direction, your vendor doesn't support you, and you're kind of stuck. So you want to avoid that. And I'll be showing how openness and disaggregation really brings innovation to your network. Basically, by being able to build your own network architecture and be able to build your own network automation stack, you can come up with the best frameworks to support you with your agility. This is your typical transport node, okay? And this is an area I have a lot of expertise in. I've been working with the CSPs in Canada for a couple of years on this. At the top, you have a router. Everybody here knows what a router is. At the bottom, you have your optical transport node, which was so well explained by Sen earlier today. The reason why these are paired is because Canada is such a big country. There are so many 100-kilometer links in Canada. I'm making a guess that there's between 50 and 75,000 nodes like this in Canada. Anybody want to challenge me? You can do that with a beer a bit later today. So the optical node, the goal of the optical node is to give reach to your IP traffic that otherwise, without the optical node, you wouldn't be able to go to such distances such as 100 kilometers. So Sen talked about that. She making my presentation easy. Lots of wiring, lots of cabling involved. It's fragile, it's a source of problems. IP technology and routing technology is quite radically different. Typically, you're going to have very different teams dealing with these technologies. So, you require at least 2 teams or an org to support this technology. Each team comes up with their own design. You have an optical transport network design, and then you have your IP network design that runs on top of that. And this is typically done through a couple of different systems. So this is what I call the complexity tax. This is the way things have always been. It hasn't been seen as a complexity. And I'm going to now show how trends in the IP optical world, when it comes to openness and disaggregation, have really allowed to change that. So you guys might be aware that you can now buy a common off-the-shelf router, okay? So, it's not Juniper, it's Cisco. It's just you buy a router that's based on standard chips, often from Broadcom. They're the leader in this area. And it performs pretty much just the same way as your traditional router. And you have the choice now. You can actually buy an operating system that runs on a router that comes from about 15 different companies. And these companies are competing a bit together, but also each one has their niche. Each one has an area where they, that's their target area, and they perform really well. So you have a lot more choice, okay? And the same thing has happened in the world of optical transport. So an optical transport node really has two layers. One of them is a conversion of electrical signals, such as what you get from your router, into an optical signal. And the lower layer is the amplification. That's what gives you your long reach. So thanks to disaggregation and thanks to open standards over the last 5 years, and thanks to also miniaturization of electronics, over the last 5 years, we now have standard plugs, okay, transceivers, that take over a lot of the functionality that used to have in these transport nodes. So what does this give us? I'm showing here two routers, 2 different sites separated by, let's say, 100 kilometers. I have a pair of plugs, low power, very inexpensive, but they implement the same functions as what you used to have in the optical transport node, and I'm able to, at a very reduced price, very reduced power, very reduced footprint, I'm able to achieve the same goal. And what do I have now? A much simpler network, okay? This can be implemented by a single, net DevOps team who understand all of these technologies together, and because they're all based on open standards, I can implement this in a single SDN controller. And again, because of open standards, much easier to integrate into the rest of my IT stack, okay? Just take a second here. It was a lot. So this actually makes the networking side, and again, I'm using transport, a lot easier. I added this slide yesterday while I was preparing the presentation. I'm taking a guess, and if I'm wrong, you can all come back to me in 3 years, say, JF, you were so full of it, but I don't think I am. So 2026 is the year that the large CSPs in Canada no longer select networking technologies without taking into account automation, okay? So I'm very convinced of this, and you can just read the press releases, for example, Bell's selection of Open RAN, et cetera. Networking solutions will be based on their ability to be integrated and their ability to be open and their ability to be automated, because that's becoming a primary concern. And this is a conversation that's having in a lot of the with CTO teams of the large CSPs, and if you're not having this conversation with your CTO team right now, I recommend you have it. I'm going to jump over this slide really quick because I know you guys are looking forward to the next phase. This slide was generated by AI. Thank you, ChatGPT. I want to bring up the fast troubleshooting. If you have a simpler network, if you have less systems to manage that network, if you have a single team that's looking at that network, guess what happens? When you have an issue, you can very rapidly troubleshoot it. This is one big advantage of network simplification using the innovations of open disaggregated networks. I'm down to my final slide. The big trend today with mobile operators, with large service providers, is autonomous networking. I don't know if you guys have heard that buzzword, but that's like the big trend today. You're only going to achieve the objectives of autonomous networking if you have a really darn good digital twin, okay? And so there's a lot of work that really the autonomous networking effort is all about having a really good digital twin. And the more information you have, the better your automation will be. So I want to come back to Equinix, who gave that nice presentation today. I've come back to it about 4 times. So Equinix have a lot of financial institutions as customers. And these financial institutions are doing things like trading on the stock market. I bet you they have crazy SLAs, okay? That network link has to be up, okay? Non-negotiable. So let's assume as an example that they need to put one of these links down for 72 hours to do some maintenance. And they got to pick another route for the traffic. Well, we talked a lot about automation, and automation could probably propose a few different links. Wouldn't you want to take into account fire conditions? So this is a reality now. Like in Canada and the US, weather events, fires, they can all impact your uptime. And again, 5th time I refer to Sen's presentation. What if the best fiber route that you've selected has had 4 marking requests in the last month because there's 4 different companies that are doing construction really close and they don't want to knock it out? Well, there's some risk associated with that link. So where I see these digital twins going, and when I see we're working with service providers on this, is digital twins will be built from the ground up, taking into account what your network really is, okay? And bringing in contextual data, okay? Weather, fires, whatever that might not be traditional networking data, but can help you make better decisions about what's going on. Larger volumes of data will be dealt really well thanks to AI, because that's something that AI does really well. And something that if you told me 3 years ago that this was happening in the market, I would have said, I don't believe it, but there's initiatives like this happening right now. I'm not a marketing guy, so I call this the AI janitor. It looks at all of your sources of data and scrubs your topology, your inventory, your configuration to improve it so that your digital twin is a true representation of your network, because the reality today is there's still a lot of automations that fail because you don't have good quality data. I'm going to leave it at this because I'm the last presentation. I'd like to thank the Tornog organizing committee, okay, on behalf of everybody. I know some of you have been working on this effort for a couple of years, and also this is possible thanks to the support of all the sponsors. So thank you very much for that, and I'll see you a bit later.